For the resistive network shown below figure, find the current in 3 ohms. Find the current in 3 ohms resistor using superposition theorem. So here in 3 ohms resistor we have to find the current using superposition theorem. So not implement superposition theorem. First of all, we must check whether there are multiple sources are there in the given circuit or not. So in this given network there are two sources, 50 volts and 25 volts voltage source. Two voltage sources are there. So we can implement superposition theorem to determine the current in this 3 ohms resistor. So first of all, I am going to assume only 50 volts voltage source is there in the circuit. For that I have removed the 25 volts voltage source. So I have replaced it with a short circuit. So I have replaced 25 volts voltage source with a short circuit. Only 50 volts voltage source is acting alone in the given circuit. So this is my modified circuit. Now let us assume due to 50 volts voltage source, current in 3 ohms is I dash current. Current in 3 ohms is I dash. So current in 3 ohms is what? I dash. Now here first of all I am going to determine the total resistance in the given circuit. So if you see here 3 ohms and 5 ohms are connected in parallel, because at this junction current will divide, which is coming from this source will divide at this junction. Therefore equivalent resistance is 10 plus 3 parallel with 5. So 3 ohms is parallel with 5. So you can rewrite it as 10 plus 3 into 5 by 3 plus 5, 10 plus 15 by 8, 10 plus 1.875 by 10 plus 1.875. So 11.875 is the total resistance in the given circuit, in this circuit. Now what is the total current? Total current is, this is the total current coming out of the source, I total. This is the total current coming out of the source. So total current is V by R equivalent. What is V? V is the 50 volts total voltage by R equivalent is the total resistance in the given circuit. 50 by 11.875, you will get 4.2 amperes. Okay. Now let us determine the current in 3 ohms resistor, that is I dash. I dash is equal to what? Total current into opposite resistance by self resistance. So I dash is, this is my I dash, this is my I dash. What is I dash? I dash is total current entering in the circuit, that is I total, into what is the opposite to 3 ohms, that is 5 ohms resistance. So 5 divided by 3 plus 5. Okay, 5 divided by 3 plus 5. Opposite resistance by self resistance plus opposite resistance. So total current is 4.2 into 5 by 3 plus 5 is 8. So simplified you will get I dash is equal to 2.625 amperes. So when only 50 volts voltage source is connected in the circuit, current in 3 ohms is this 2.625 amperes. Now let us consider only 25 volts voltage source is acting alone. That means this 50 volts voltage source, what has happened to it? It has been replaced by a short circuit. Okay. And when only 25 volts voltage source is there in this given circuit, let us assume current in 3 ohms resistor is I double dash. Current in 3 ohms is I double dash. So first of all I am going to determine the total resistance in the given circuit. So total resistance is how much? It is 5 plus 3 parallel with 10. Now why? Because the current will come out of this source from this positive terminal, it will flow like this. At this junction what is happening? Current is dividing into two parts. So current is dividing in between 10 ohms and 3 ohms. So 3 is parallel with 10. Okay, this whole combination is in series with 5. Okay, so 3 ohms is parallel to 10 ohms. 3 ohms is parallel to 10 ohms plus 5. So 5 plus 3 into 10 by 3 plus 10. So just further simplify, you will get 5 plus 30 by 13, 5 plus 2.3, and R equivalent. Total resistance is 7.3. So what is the total current that is coming out of this source? I total. This is I total. So total current coming out of this source I total is V by R equivalent, that is equal to 25 by 7.3, that is equal to 3.42 amperes. This is the total current coming out of this source. Okay. Now current in 3 ohms, that is I double dash. Current in 3 ohms, that is I double dash, is equal to total current entering the junction, where current is dividing here. Total current entering the junction is 3.42 into what is opposite to the 3 ohms, that is 10 ohms. Okay, current is dividing between 10 and 3, therefore 10 is opposite to 3. Therefore 10 divided by opposite resistance by self resistance plus opposite resistance. So 10 by 3 plus 10. Just solve it, you will get 3.42 into 10 by 13. You just simplify, if you will get 2.625 amperes. So current in 3 ohms resistor, when only 25 volts voltage source is there, current value is how much? 2.625 amperes. Now let us go to the next step. When both voltage sources are acting in the given circuit, when 50 volts as well as 25 volts, both sources are there in the circuit, let us assume current in 3 ohms is some I amperes of current flows through 3 ohms resistor. Okay, and in order to determine current in 3 ohms, I am going for nodal analysis, that is Kirchhoff's current law. I am going to implement Kirchhoff's current law here, KCL. Okay, and in order to implement Kirchhoff's current law, I am going to assume the node voltage as V, and I am going to assume some node current directions at the node. So I have assumed the current from this source enters into this node, current from this source enters into this node. From this node, current leaves towards 3 ohms. Two currents are entering, one current is leaving the node. Okay, so let us write down now. Let us apply KCL. Algebraic sum of entering currents equal to algebraic sum of leaving currents. So entering currents are what? Entering current is traveling from 50 to V. So 50 minus V by how much? V by R. R value is 10. 50 minus V by 10. Next, current is traveling from 25 volts to V. So current is how much? 25 minus V by how much is the resistance here? 5. So 25 minus V by 5 equal to leaving current. What is the leaving current? V minus here, what is it? Reference voltage of 0 volts is there. This is our reference node, so whose value is 0 volts. So V minus 0 by 3. This is 3. Okay, so these are the currents. So 50 minus V by 10 plus 25 minus V by 5 equal to V by 3. 50 minus V by 10 plus 25 minus V by 5, I have sent this V minus V by 3 to left side. So minus V by 3 equal to 0. So 50 by 10 minus V by 10 plus 25 by 5 minus V by 5 minus V by 3 equal to 0. I have simplified, I have split these two terms, this term and this term, I have split it. Okay, and I have further 50 by 10 is 5, 25 by 5 is 5. So I have got here 5 minus V by 10 plus 5 minus V by 5 minus V by 3 equal to 0. Just simplify it further. You will get minus 15V minus 30V minus 50V by 150 equal to minus 10. Send 150 to right side, you will get minus 1500, and you just add all these three terms, you will get minus 95. So what is V? Node voltage is 15.78 volts. This is the node voltage. Now I know node voltage. So what I can do is, I can determine the current in 3 ohms. So what is the current in 3 ohms? V minus 0 by 3. V is what? 15.78. So 15.78 minus 0 by 3, you will get I equal to 5.26. When both sources are acting in the given circuit, Current in this circuit is 5.26. Now let us see, let us verify superposition theorem here. What is it? I should be equal to I dash plus I double dash. What is I value? 5.26. I dash is 2.625. What is I double dash? 2.625. So you just add these two, you will get 5.26 is approximately equal to 5.25. Okay, so the currents, algebraic sum of currents when individual sources are there is that algebraic sum is equal to the current flowing in the same element when all sources are there. So superposition theorem is verified. Now what is the current in 3 ohms resistor? That is 5.26 amperes. Current in 3 ohms resistor is 5.26 amperes.